Hello, everyone. I am Abdulkabir Musa, a software engineer and founder of Brevi. Today, I am to case a topic that's um, about a small model, like the future of small model isn't about how big it is. It's much more about how powerful, smaller, faster, and how privacy it is. So, before moving forward, let's first talk about how we are chasing the wrong metrics. When you look into most big models nowadays, they they actually did a lot more compute more than most tasks actually required. Most tasks required few amount of computing stuff. But due to the fact that most of these models are like they are based on cloud, they required more processing GPUs and more infrastructure to process the requests posted by processed by posted by a user. So which leads to requiring more compute more than the task actually required. So and when you look into most of these models, they are trained or deployed, well, I should say most of these frontier models, because when you look at most of these models that can do more tasks, they are that are very, very powerful. Like we have the GPT family there by OpenAI, we have the Claude models by the Anthropic and Gemini, DeepSeek, and many more. So when you look at how they are trained, deployed, it actually costs much more than we can even imagine of. And when you look at it, most of them they are trained and deployed around roughly $100 million to train all these models and deploy them to end users so that they can use it. And when you look at this cost is nothing, it's far more beyond most people can actually believe. So, and when you look at most of these models, they are cloud-based, which means that your datas are not private. Like you can't literally say the datas or the informations you are giving out to most of these models are actually safe within, like they actually safe, nobody knows about it. So it means that you are risking your private when having interactions with most of these models. This now literally leads to the fact that bigger models are impressive, to be precise, because they can do multitask when you look at most of these frontier models. But the key point is that impressive is not equal the right tools or the right deployment. Because if they are impressive, but they are risking a lot of users, data, and other many other things that we are going to be looking into, this isn't really good, to be precise. So now, before we move forward, let's talk about small model, because since the topic of these discussions is more about small model. So what exactly are small models? So small models are typically around 1 to 7 parameters. So what are these what are these models? They are models that can run on your local devices, whether your mobile phones, your laptops, and they literally doesn't require GPU server. So, and these models are fine-tuned for a specific task, not a general purpose task, like a models that is fine-tuned for medical stuff, or for code review only, or for customer support. So they are not general purpose models. Like they can't do everything. When you look into ChatGPT, you ask it to do a research on medical stuff, it will do it. You ask it to write code, it will do it. You ask it to do many other tasks you can even imagine of. It means that most of these frontier models, like all these deployed models you can see, they are much more about general purpose tasks. They can do everything. So they are not built or fine-tuned for a specific task. And one more thing is that small modules are privacy first because they are built for most of our devices. It means that all data that are being used by this module, they are stored within your device. Nothing leave your devices. Like everything stays within your device. So which means that there is no external API call, right? And there's no cloud dependency, latency, or something, nothing else. So I don't know if anyone can have ever heard about most like some of these small modules, like if anyone can list it. But let's just quickly list some of these modules because most of them are like they are built by most of the big tech companies. Like the first one is the Pi 3 Mini, which was built by Microsoft. And we have the other model, which was built by Google Gamma 2B. So these models, as you can see, most of them they are within the range of 1 billion parameters and roughly around 7 billion parameters. We have Mistral 7B there, right? 7 billion parameters, which is Mistral built by Mistral AI. We have the Llama 3.2, which is 1 billion parameters by the Meta company. So all these models, they are within the range of 1 billion parameters and 7 billion parameters, which means these models are very, very small compared to most of these frontier models that's within our trillions of parameters. Understand? So most of these models, they can run locally within your devices, and they are very powerful and fine-tuned for a specific or a particular task. Now, let's quickly talk about why most of these small modules wins in the real world scenario, like when it's come to real world. Because most people, one thing I quickly want to highlight is that most people believe that most of these frontier modules we interact with, they are much more powerful, and because they are those we use daily in most cases for most people, they believe that those are the models that are actually powerful. Whereas most people actually not looking at the other way around, whereby most of these built-in models within our devices, how powerful they are and how they are fine-tuned, like how they are actually solving the problems of for a specific task within our devices. Now, let's quickly highlight the first, because we have four reasons why we can actually we are going to be using to back it up that small models they wins in the real world scenario far more than the frontier models. So the first is privacy first. So when you look at when you look into most of these cloud-based models like the frontier models, they lacked privacy because it is 100% sure that your data doesn't stay within your device. It's being stored on cloud infrastructure, which means that it means that external the host, like the host of your data, they can actually see all the conversations your data are not. It means that your data isn't safe, right? So comparing that with small models, it's nothing leaves your device. Everything, your conversation, interactions with the model, all the processing, all the informations result, everything stay within your devices, which means there is no data is leaving your device, no server logs, and there is no third party exposure to your privacy. So this is one big thing that actually follows the rules of GDPR and hyper and growing of user trust. You know, whenever you want to go user trust, most user actually looks forward to is my data safe? Like, yeah, my privacy isn't being lost to external users or something like that. So that's one of the first reason why small models they are actually much more better than any other big models. Now, second thing is the real-time speed. So nothing, this is not something we even need to debate about, because when you compare something very local to you or close to you and something much more far away to you, you know that the one that is close to you will be much more faster to get or to access more than the one that is much more far to you. So when you compare the small models is within your mobile phone, like, right? So it means that even though without internet or without network, right, you can use it and it will be much more fast. There's no latency. Like we have 0% of latency. So it means that small models, they are very, very fast when it comes to responding and handling any apart from data privacy, they are very fast, right? They are crazily very fast. Comparing that with cloud-based models, like all these big parameters of data sets and all these models deployed on cloud, external cloud infrastructure, comparing times of request, comparing that with amount of time that cloud infrastructure we need to process your data, your informations, or your request, and comparing, adding that up with time that it will take for the cloud to return the response. So comparing all this together, it will take much more time than local model to process and give you an instant response, right? So it means that let's just quickly round it up in such a way that if small models takes within 100 milliseconds to handle all your requests, process everything, it means that external API compare adding all the latency and everything together, it will take roughly around 500 milliseconds to 2 seconds. Get so, which means that this there is a very huge gap and differences between the two when it comes to real-time speed. And when we compare this with stuff like voice notes or some on-device search and other features, it can have an absolute there will definitely be very, very absolute gap between these the latencies. So now the third reason why small model is much more bigger in real world scenario is that um the cost. When you look into the cost, small models that which are within your mobile or your devices, they have zero scale and they cost you nothing, like they cost you zero amount to use them. Comparing that with external models like all these frontier models, they cost within 0.01 to 0.03, comparing depending on which company or which API call you are saying API you are using, right? This costs you an actual money. So which means that the on-device models cost you zero amount to use them, comparing that with an API call or an external model. So this is also another efficiency, like there is efficiency there comparing the case whereby you don't have to pay anything and the case whereby you need to pay some amount of dollars. So and this on-device model that costs you nothing, you can use it countless amounts of you can use it anytime. Like you can use it millions of times, billions of times in a day without costing you zero amount of money. And when you look into these API calls, especially most developers in the room, they know that they have to be very careful when sending requests because per request there is an amount that is being cost for it. Like you send 100 requests in a day, that's 100 requests times the amount of API calls, which you will be very careful to use. And so that is also one critical gap, like one benefit, very huge gap and benefit between small models and a big models that was deployed on an external infrastructure. So the last here is offline reliability. Like most hospitals, planes, remote areas, and some of market that has low bandwidth. So most of them, they preferred offline accessibility to some tools. If you are using an API call, right? So it means that you need a way stronger, a standard, or a better network that can make the request and get back a response. But considering that with a scenario or within a local community whereby the network is really, really bad, like it has bad connectivity issues or something like that, your users, if you are using most of these API, if you are using API calls to use to do a lot of things. So in this scenario, users won't be able to use your tool. They won't be able to access this feature, or this model won't be accessible in that kind of scenario. Comparing that with on-device models. So on-device models, they can do anything anywhere because by default they didn't need external network. They didn't need network to function. They are built within the devices. So this is one of the reasons why most hospitals, planes, and most remote areas, they used or they preferred small modules that can solve problem for them anytime or at their own convenient places, like anywhere they are. It can solve the problem they really want. So that's one of the reasons why when you look into um, building, when there is a model that was fine-tuned for a specific task, and can which it means that people can use that model anywhere they are, whether there is network or there's no network, whether there is latency, which doesn't even affect that small model. So this is one of the, this is one of the benefits, like a perfect scenario for real world cases for most of these small models. Now let's talk about the cloud AI privacy problems. So what are the cloud API privacy like? How does the privacy on the, like, your data's on the cloud, how does it affect your privacy? Like, what are the concerns, right? I don't know if there's anyone here that can highlight what is meant by privacy when it comes to cloud AI for us. But let me just quickly highlight that. Let's just quickly highlight it. So now we will look into two scenario here. We look into the cloud AI risk and we look into the edge AI solution. Now, when you look into the AI risk for your, whether your data or some few other things, in most of these cases, whenever you send a request or interact with most of these AI infrastructure or your models that was deployed on an external vendor server. On each request from different users, they log different queries and all the data that is being sent, they log it, whether they log it for sometimes for security reasons and sometimes to train or retrain their models. So in these cases, whenever you send any data, if it is something very private to you, it will be logged on their server, which means that your data or your privacy stuff has been exposed to the vendor. That's one of the reasons why your privacy is at risk when it comes to cloud-based deployment models. So, and when you look, second thing is healthcare and legal data exposure risk. Most of these healthcare, most of the their most of the healthcare people who went for health solutions, like they want their information, their data to be private. They don't want anyone to gain access to it. And when you look into legal risk, like lawyers and all these things, they handles most of their clients' informations with confidential. So they didn't want any third party or any person to get access to such kind of informations or such kind of data. So this is one of the way we need to be very careful about data privacy first before, because when such kind of company, like whether an healthcare or legal company, they are using an external models to a bigger model, they think that can solve real world problem, that can solve much more bigger problem for them. They integrate it into their system, and all user informations, whether it is for healthcare or legal scenario for these cases, and they sent it to their server, and their data has been gained, are being exposed there, used to retrain models and other things, like it was exposed to the vendors. It means that there's no privacy anymore. So we need to be very, very careful. That is why most healthcare and legal company, they preferred to use small models. They prefer small models than most of these frontier level model. So it's the third list here, what we'll be highlighting here is vendor policy changes affect your data. Assuming now that the initially your vendors, in their terms and privacy policy, they said they are not accessing your data is fully encrypted. They are external company, like they can change their privacy or their policy anytime. And whenever they change their policy, they can easily get access or gain access to your data, which you can't really do anything about, because they've already highlighted it in their non-policy. So this is one of the risks most people are trying to avoid about their privacy. So one more thing is jurisdiction and compliance complexity. You know, laws in different jurisdiction is different from another jurisdiction. So to comply with all these rules and regulations, most it's much more okay, instead of going to and fro, it is much more okay to have a small models that can solve an actual solution for you, rather than just jumping around with some external and some external cloud-based models. So the last on the cloud AI risk is about the breach of data and breach of all queries. Like most of your data, as I said earlier, most of your data can be seen by your vendor, right? So sometimes they can view all the queries, like all the queries you are sending in a day, and sometimes it can be few of it. It can be just few of it, but in most cases you can't really see, because you are not an engineer there, or you are part of the team, or you are part of the stakeholders that really see into most of the things. So it's better to go for small models in most edge cases than going for something you won't have peace of mind for. So now let's quickly look into how most small models handles solve these AI solutions. So one first thing is that data never leaves your device. Whenever you are interacting with all these small models, all the data, all the interaction processing, everything stays within your mobile devices or your laptops or your anything. So the second thing is that no retention, no logs, no third party, no retention, right? And there is no log. They are not logging your data, like informations about what chat or what the conversations that you're having with most of these models. And there's no third party access. Nobody can gain data, gain info, like access to those informations um you have within your device, or you are interacting with within the between you and the model. So now the next step is the works in air gaps environment. So it's literally can work anywhere. Like if there is no network, like we have zero, you have no network in an in a scenario or in a condition, or a community where there is very huge amount, like there is no internet connectivity. So it will definitely work, because it's not, these models does not require they doesn't require network primarily. So they are integrated, like fully integrated within your devices, which means it can be easily accessible anytime you want it. So one more thing is that they have the compliance with GDPR and HIPAA by default. Like the architecture follows the data privacy rules by the EU's and other compliances. So now we have user trust. When you know that your data does not leave your device, you have trust in such kind of scenario, like more than your data has been transported or moved to some external servers you doesn't have control over. So in this kind of scenario, most user trust in such kind of product more than products that actually gain access to their privacy. So now let's quickly look into this slide. This slide here will be giving in more insight into the gap, like the very huge amount of gap between these small models and other models, like small models that are within your devices and models which are deployed externally, or we should say the frontier models. So the first thing is that um on-device models, they are much more faster, as we've already said. So they are more like very, very fast, more than most frontier level models, because when you compare on devices with API calls, we are just trying to, because when you look into on device doesn't have latency or any server issue or something. No, everything runs within your device. As much as you are able to power your mobile and it has some power on it, you can use this on device mode anytime. Like they are much more faster. Comparing that with API, because there's a lot of things that can cause API issues, like the API responding, whether we're responding late. It might be the maintenance issue. Recently, Claude, they are doing some maintenance within their platform. So this caused a lot of API requests to take even more than 2 minutes, 5 minutes, 10 minutes for you to get back a response. Comparing this kind of scenario with on-device models. On-device models doesn't need, or there's no maintenance, nothing. You just it handles your request, process it, and give you back a response very, very fast. So now that's the first thing. The second thing is that 99% cost. Like, there's not, you don't have to pay for anything when for small models, because it already comes along with your most of your devices, your laptops, your mobile phones, and other devices. So most of these models, small models, they are built in, like they are built in into most of your device, which means that you don't have to pay for extra cost, and they won't be charging you externally for it. So comparing this with cloud-based API calls, so every time you send a request to the server, they charge for it. Whenever they give you back response, they charge for it. So it means that or each by there will be a charge, a certain amount of charge for each API calls, which means you also need to think about the cost you have to pay for. So, and one more thing is that 7 billion parameters. When you look, as we've already said earlier, that small models range between 1 billion parameters to around 7 billion parameters. So when you look into these 7 billion parameters, most of these 7 billion parameters, like on device small models, they can even match with GPT-3. A small models within your device can even have same powering processing. Like they are much more intelligent the same way as GPT-3, which is very good, right? So, and they are just fine-tuned for a particular task, which means that something that is fine-tuned for a particular task can actually go and do much more thing than a model that is fine-tuned for a general purpose task. You understand that? It's like someone that focus on a specific, like a specific concept, like you want to become a doctor, and comparing that with someone that is just gambling around, like I want to become a doctor, I want to become an engineer, such kind of person won't really have a direction. So comparing that with someone that only focus on a specific task, so that's very huge amount of gap. And the very last thing is that it has zero latency. There is nothing like there is cloud issue, or there is network problem, nothing, because it's completely offline, and completely offline is equal, triple equal, like strict equal to the first fact that it is much more faster, than like it will be always faster. So this is very good when you look into small models. Small models, they are absolutely good, absolutely powerful. So efficiency is not compromised when it comes to small model, but for real deployment, it's the competitive advantage. So now let's quickly look into how small models are evolving. So now you might not be feeling like, oh, these small models, I have not experienced it or something like that. But I don't know if there's anyone here that has already experienced small models in a real world scenario, like they've actually have like failed it, like they've experienced it, use it in some, whether on your laptop, on your mobile. But when you look into it very carefully, in most modern tools, most of these small models are being integrated into it. So let's start from the healthcare scenario. So most healthcare nowadays are now having all most of these small models to summarize some clinical notes for patient data and some other general stuffs, which means that all the data that will be used to process and do all the necessary things, they are not leaving the healthcare database, or the healthcare system, because they are not connecting to external software, and everything stays on their devices. So which keeps them safe, and it also keeps their patient data confidential. So one more thing is about mobile apps. Mobile apps has already integrated it much more everywhere nowadays, because most people that use the latest Apple intelligence, or Apple iPhones, most people that use latest Pixel AI, most of them have crazy AI stuff on their devices, and these intelligence comes from the benefit of most of these small models. Because when you look into Apple, for instance, the latest Apple has this feature of Siri, like that have Siri now has huge amount of improvements. Like you can use it anywhere within the app. Or I'm not an Apple user, but I believe I believe that there is a lot of features that AI can do for you within their latest mobile phone. And when you look into Google Pixel, there is this feature Pixel added, like AI feature. Whenever you snap your stuff, you can clear something as clear, like just highlight where you want to clear, and it will just do the AI stuff and remove everything, like something like a background remover or something remover. We also have these Samsung also have this feature whereby you can snap anyway and just prompt it that add this to this stuff. Like for instance, you snap an ocean, then you just prompt it that add a ship on this ocean, and you just see boom, you see a ship on it. So this is one of the intelligence of on-device um models. So most of these all these models that are doing all this crazy stuff, they are on device, they are not external stuff. So everything is built, they are integrated into the chip of the um your devices. So they are very, very smart, and they are privacy first. You are not losing any data there. So you are not extended, or the companies are not gaining access to the most of these data. So which keeps your data and your informations confidential. So now one more thing is that the next step is the manufacturing phase. So in the manufacturing phase, they also have gained a lot of benefits from small models due to the fact that they now have quality control AI on factory floor machines with zero internet dependency. So when something when you look into it closely, you notice that when something needs internet to work, so in most cases, if there's no internet or network connectivity, Wi-Fi, there's no mobile data, in most cases you won't be able to do anything. Comparing that with something that doesn't require most of these things to work, like you just need it and it will be there for you to use. So it's actually very, very crazy and good. So now the next step is the emerging markets. So this is also one of the very huge amount. This also AI just also add a lot of very huge amount of benefit to this space, because nowadays we can now see various amount of tools being that are using AI, like AI integrated tools, AI powered, this AI, everything is now AI powered, right? So everywhere, customer care, all tools are now using AI. So it's me. And apart from that, new emerging tools are now coming up whereby they are AI agents are fully like they are AI agents, like they are fully integrated or tightened with AIs. So it means that with this, most of them are using small models, which means that they are optimized for low bandwidth and zero low cost. In most cases, people don't want to pay much, and whenever you have an on-device tool or something that is there for you to make use of anytime, people usually benefit from it a lot. And when you look at the market within the Africa community or the Africa space, you will notice that there are still a lot of huge communities where there is still lack of standard or good connectivity to network. So this kind of scenario, this kind of small models, they can also be beneficiary, like they can also make use of, they can also gain access to such kind of powerful models and advanced models too. So the next thing is about the legal and finance community. So when it comes to legal and finance, there's a lot of things AI is now helping them to handle nowadays, and most of them depend. I did see roughly around 80% to 90%. They depend on small models, because it's when it comes to small model, small model equal privacy first. So, and one of the communities or one of the associations that needs access to privacy first. Apart, like we have healthcare, we've already mentioned them, healthcare is there. And We also have the legal and finance. So they are very critical. Like they need to handle users' data as like as their life, right? So they need to become very confidential about users' data. So now legal and finance, they use most of these small models to review contracts, like they used to review them, and finances too, they need to check or do some major analysis on users data amount and a lot of different things. So most of these firms, they don't want to really risk their confidential documents, so they just don't want it to leave their own personal server. So they prefer that more than exposing users data or their own company confidential data to move from their own server to another company, to another hosting platform. So the last thing is most of the autonomous stuff, like we have the automotive. So when we look into the modern cars that are being built nowadays, especially when you look into Tesla company, which they are known for that. So AI is the crucial, or it is the roots and background of such kind of companies. So they use AI to power a lot, handles traffic, they use it to handle traffic and sync or link it strictly with GPS to monitors a lot of things around the car, whether it's on the way or it's about to park, or a lot of different stuff. So whether it is also in car, so they have in car AI assistance that responds instantly, regardless of signal quality, which means that even though if there is no network or there is down, all the network within this community or the area is down. So you still have the small modules that can power, which can literally powers the car and ask for any help and do some certain amount of things for it. So this is one of just some of it. We have tons of examples. Now, one question we need to stop asking is that we need to stop asking a models how big a model is. Instead, we need to start asking the question that how does this model fit, like how does this model fit for the task at hand? Or how can these modules serve the purpose we truly want it to do? So, and let's just quickly look into different scenario. Like we look into the hype mindset. Most people have, like almost 80% of people have this mindset. So, and look into the other way around, which is the efficiency mindset, which we literally want most people to have. So the hype mindset is much more about, people really cares much about more parameters. They believe that more parameters equal to better, which is truly wrong. And most people also believe that one model for everything actually solves everything and it's good to go with that, which is not really good, because when you look at it very deeply in such a way that um when you can do everything, it's like it's like you don't really, you can't really do much. You should be fine tuned when the model is fine tuned for a specific task, or you are good in a specific task. It means that that's your field, you can do more than we can imagine of, and you are really good. You have enough of data or enough of research and knowledge within that space. Is much more good, better or good than someone that have variety of understand. You just grab from here, grab from that, here, that, and you don't really have a deep understanding of all these spaces. So the next thing is that we have the cloud first and privacy later. So most of these frontier models, which has a model and can do everything, they are cloud first, right? They are cloud first, and they didn't really really care about privacy, right? So because at the end, it is 100% sure that your data are being stored in the vendor server. So which means that you are not in control of your data. So, and most people really cares about benchmark, leaderboard, divine value. So most, if you are a technical person, you will understand how they handles this benchmark stuff. So most people really care about, oh, Gemini is at the top this week. Oh, GPT is at the top another week or something like that. That's actually what most people actually most people cares about, and that um defines a lot of things, because when you look into it deeply, benchmark doesn't really do anything. It's much more about a lot of different, entirely different stuffs. So we have users accept latency as given. Yeah, and truly, this is something most people don't know, most people don't look into very deeply. We really accept the latency as it is given, right? Because if ChatGPT is down for like 2 hours, people will feel like, oh, post everywhere like ChatGPT is down. Oh, I can't do anything. I can't do this. I can't do that. Everybody will be jobless or won't be able to do anything within that time frame. So, which is really not good. Comparing that with on device where you don't really need, there's no server down, there's nothing like latency, there's nothing like network issue. You want it, you want it at a certain amount of time. You just move forward and start using it. So that is much more better. And so now let's look into the efficiency mindset, where we'll be correcting the hype mindset. So it's the first is about the right size for the task. So we need the right size for the task. Like if it is, if we need if the model would solve, we only need around 2 billion parameters to solve a specific task. That's it. We should just go with the 2 billion parameters and make sure that it actually solves what we actually need it for. And that's it. That is what really matters. That's what really matters. We don't need very huge amounts of parameters to solve a specific task. If a specific task can be solved by a certain amount, like a few amounts of parameters, that's just it, right? So we need to shift our mindset from more parameters, like we need more parameters to solve a specific task. No, we need a certain amount of parameters that can actually solve a specific task, and let's just go for that. So the second is specialized beat generalized. When something that I've already said and emphasized much more about is when something is specialized, when you are specialized, for instance, on a specific field, you can beat someone that generalizes everything. You get, so you can like beat and overcome so anything. Like when something is specialized, it's much more there is very huge amount of gap between it and some. So when something is a generalized stuff, so that's something we really need to shift our mindset towards. So next is privacy by architecture. When a model is built on privacy, on privacy. So we believe we should know that this really cares about us. Like your data is the priority. How your data is being saved. Like your data it means that your data are being handled with confidential. They are not leaking it. They are not exposing it to external services. So that should be you should be very grateful about that. So it's something we need to shift our mindset towards. Like we shouldn't care about, oh, my privacy is later. I just want to make sure that I'm using this stuff. So you don't really care about your privacy. So we need to shift our mindset to my privacy is the first thing, instead of using like the tool first. No, not the tool first, but privacy should be the first. Like we should prioritize it. So now one more thing is about the real world deployment defined value. So when all the most of these small models come like starting from the scenario whereby most of these small models have been tested, fine-tuned, um like they are trying they are using, like looking into how they are fitting into real world scenarios. And by the time they are used in real world scenario whereby it is benefiting most people, so in that case it has add enough value to human being. So that actually makes sense. It really makes sense. So that's actually what we should look forward to, like a small models that actually solve a real world problem, right? So that's how we should move. Not like we should be looking into a benchmark like, oh, GBT are the first, Gemini, Claude, DeepSeek are the first on the leaderboard this week or something like that. So, and we also need to look into user also deserves instance, not private, not prior with private AI, right? So not privacy later. We also need user deserve instance. Like the user deserve instance there really means that you don't want latency. Like you don't want something your response to be lagging or to be taking some couple of while. They should be notifying you that, oh, we are doing some maintenance, server issue, we are trying to rectify this problem or something like that. You just want to get everything instantly. There is no delay. You want it and you just gain access to it. So user also need to prioritize such kind of scenario. So now that is it. And to round it up with everything, I really want to like share this quote with you guys. Like the most powerful AI isn't the one with the most parameters. It isn't when you look into the reason why I highlighted this quote is about that, when you look into, let me quickly name some few couple of models like um we have the GBT5 there, the latest with I think 5.2, which has almost around roughly whether trillions of parameters when you look into Claude Opus. So most of these latest models, they have either more than trillions of parameters. DeepSeek is there, Mistral, and many, many other um, frontier level models. So they have billions, trillions of parameters. So we shouldn't really care about more parameter. Which one has the most parameters? That does not really define um models. So it's the one that's running on your device right now. The one running on your device, it really cares much more about you. It really cares much more about you. Like it takes your privacy first. You get instant feedback. There is no latency. Like you have no, there's no latency like network connectivity issue and many many other advantages that comes from most of these small models. So now we need to care about the efficiency is a feature, not a compromise. So this is another quote I am sharing with you guys. So we should know that efficiency is a feature, not a compromise. So privacy is only solved on device. Your device will actually solve your privacy. So it means that you have access to this, you can control it, right? So you should always care about your privacy. And the privacy can only be brought to you through your own personal devices. So, and the third is that small plus specialized is greater than, not even doesn't can never have equal to, is greater than large plus general. So when something is smaller and it's specialized in a specific field or is specialized in a specific task, is more that's such kind of model is much more better and very, very powerful than a very large amount of model with tons of parameters and it is doing handling very general task. So it means that you can't compare these tools. You can't compare these two scenarios. So that's it, guys. I really appreciate everything. Thank you, guys. Once again, my name is Abdulkabir Musa. I'm founder of Brivi. All right, nice having this conversation with you.